All right, AP, here is sample exercise 3.91. We're calculating percent yield. Methanol, the formula CH3OH, also called methyl alcohol, is the simplest alcohol. It is used as fuel in race cars and is a potential replacement for gasoline. Methanol can be manufactured by a combination of gaseous carbon monoxide and hydrogen. So suppose 68.5 kilograms of carbon monoxide gas is reacted with 8.60 kilograms of hydrogen gas. Calculate the theoretical yield of methanol if 3.57 times 10 to the fourth grams of methanol is actually produced. What is the percent yield of methanol? Go ahead and press pause now because here comes the solution. So first, we must find out which reactant is limiting, the hydrogen or the carbon monoxide. And so we need to look first at the balanced equation. Next, we must calculate the moles of reactants because we need to figure out, we need to be able to use the mole ratios to figure out which substance is limiting. And so we convert kilograms into grams first, right? Because molar mass as a conversion factor is only going to be able to use grams. So get rid of the kilograms, go into grams, then use the molar masses of each of the substances, each of the reactants, to generate a mole amount of each substance. So we have 2.44 times 10 to the third moles of carbon monoxide. We have 4.27 times 10 to the third moles of hydrogen gas. So to determine which reactant is limiting, we compare the mole ratio of hydrogen and carbon monoxide that is required by a balanced equation. And so the ratio of hydrogen to carbon monoxide is 2 to 1, right? 2 to 1. And so if we divide that out, that's 2. It's a whole number. It's 2. But the actual ratio of stuff we have, right, using these two numbers, the stuff we actually have from the masses, we have this amount of stuff. So we actually have, again, moles of H2 over moles of carbon monoxide. We're dividing the 4.27 times 10 to the third by 2.44 times 10 to the third. That gives us a mole ratio of 1.75. Right? Notice it's less than 2. We'll scoot up. So since the actual mole ratio of hydrogen to carbon monoxide is smaller than the required ratio, that means that hydrogen is limiting. We therefore must use the amount of H2 because it's limiting and the mole ratio between hydrogen and methanol to determine the maximum amount of methanol that can be produced. So we take our amount of methanol that our amount of hydrogen that's actually being consumed, right? All of the limiting reactant reacts, it's being consumed, it's going away. We're going to convert that into moles of methanol. And so now we have a value how much methanol is being made. Simply using the molar mass of methanol, which is 32.04 grams per mole, we can now calculate the theoretical yield, and it'll be in grams. So we're going to take this mole value of ethanol, use the molar mass of ethanol. Moles of ethanol, methanol will cancel out, and we have 6.86 times 10 to the fourth grams of methanol. Therefore, from the amount of reactants given, the maximum amount of methanol that can be formed is 6.86 times 10 to the fourth grams. This is known as the theoretical yield. We're going to finish off with the percent yield. Okay, so what if 3.57 times 10 to the fourth grams of methanol is actually produced? We're going to take our actual yield and divide it by our theoretical yield, again, what we just calculated here. Turn that into a percentage by multiplying by 100%, and we can generate the very simple calculation, very simple value of 52.0%. So this is a 52.0% yield.